Markets today are flooded with smart systems that can understand our needs and provide services as and when required. Take the example of your smart car interacting with you while parking, or your smart devices at home sensing your presence and providing you information like the room temperature as you enter your home. These are powered by cyber physical systems, which is a new class of engineered system that integrate computation and physical processes. It encompasses technology areas of cybernetics, mechatronics, design, embedded systems, Internet of Things, artificial intelligence, and much more. Some of the fields that are already reaping the benefits of CPS are medical monitoring, process control systems, robotic systems, and automatic pilot avionics. Though useful and available, we still do not fully understand why cyber-physical systems are and how they are useful to us. So today, we embark on a journey to understand and explore the world that is cyber-physical systems. Let's begin with its origin. Dr. Helen Gill, who specializes in computer and information science and engineering at the National Science Foundation in the United States of America, coined the term cyber-physical systems as it emerged in 2006.
Cyber-physical systems, this is all of future. This is about convergence of technologies, communication, computing, decision-making, perception, and autonomous action. So when you have all of these technologies together, you have digital components, which is communication, computing, decision-making through artificial intelligence. And then you also have the machine or the physical part, which is related to perception, gathering data, and arms that would give it action. So perception to action, and this is all of your future. So examples are manufacturing in Industry 4.0, where you have intelligent machines that do self-diagnosis. They also do the decision-making, fault diagnosis. Then you have autonomous vehicles going deep under the ocean, exploring there, going up in the space, and even small things like pilotless cars.
Let's break it down. CPS is about the intersection, not the union, of the physical and the cyber. Cyberspace is the notional environment in which communication over computer networks occurs. It combines engineering models and methods from mechanical, environmental, civil, electrical, biomedical, chemical, aeronautical, and industrial engineering with models and methods of computer sciences. By using a combination of machines, sensory devices, embedded computational intelligence, and various communication mechanisms, CPS monitor physical elements with computer-based algorithms tied to the internet. This means they are capable of independently functioning based on their physical surroundings. Before we delve deeper into the science of cyber-physical systems, let's get a broader understanding of the fields likely to benefit from this new cyber revolution. Cyber-physical systems have the potential to transform distribution of electricity by integrating the behavior and actions of all users connected to it. The benefits of a seamless intelligent system would include self-automation and seamlessly balancing power supply due to varying energy requirements of customers across regions. Integrating renewable power sources, reduction of losses, and enhanced safety. Some other areas where cyber info systems are likely to have a major impact are smart water networks to reduce leakage, better groundwater management, just to name a few. So now that we have a better idea of its practical benefits, let's dive in. CPS is often associated with the term cyberspace, but the roots of the term are older and deeper. It would be more accurate to view the terms cyberspace and cyber-physical systems as stemming from the same root, cybernetics, rather than viewing one as being derived from the other. So, to understand CPS and its objectives, we should also understand the role of cyberspace and cybernetics. Norbert Wiener, an American mathematician, philosopher and professor of mathematics at the Massachusetts Institute of Technology, coined the term cybernetics during the World War II. Wiener pioneered the technology for automatic aiming and firing of anti-aircraft guns. Although the mechanism he used did not involve digital computers, the principles involved were similar to those used today in computer-based feedback control systems, which is a conjunction of physical processes, computation and communication. To understand the practical applications of cyber-physical systems and research being carried out at the Indian Institute of Technology, Delhi, we met Professor S.K. Saha and his team of researchers in the Department of Mechanical Engineering.
Cyber physical system includes robotics, the IoT, Internet of Things, the smart manufacturing. This is required in India in order to improve the quality of the life in the villages as well as in the urban places. Through robotics, telemedicines, I can inquire, a doctor sitting in the city can inquire on almost in a live mode to a patient there, and if in case certain emergencies is required, immediately the person can be brought in, or even more advanced, if we have the robots doing certain tasks, maybe assisting to do something, people to move from here and there. So then robots can also help doing things. So the quality of the city life can be also exported to the villages and other remote places.
Cyber-physical systems are heralded as the next paradigm shift in technology that can exponentially spur growth and development. CPS are intelligent, autonomous, and efficient cyber-physical systems expected to drive innovation in sectors as diverse as agriculture, water, energy, transportation, infrastructure, security, health, and manufacturing. Given this potential and India's focus on technology, the Union Cabinet chaired by Prime Minister Shri Narendra Modi launched the National Mission on Interdisciplinary Cyber-Physical Systems in 2018. It is being implemented by the Department of Science and Technology, Government of India, at a total outlay of Rs 3,660 crores over 5 years. 15 technology innovation hubs or nodal centers are spearheading the research activities. The mission is mandated to coordinate and build linkages with research institutes and labs in India as well as internationally. Collaborations with industry will help deliver commercial technology and products to build a vibrant innovation ecosystem by providing a reliable platform for technology-based startups and entrepreneurs, thus fostering research innovation, world-class technology and product development.
In the initial stage, the identification of the host institutes, establishment of TAH and as well as the TBIs is the first target for us. We have almost we completed that particular phase. The next phase, in fact, we will be working on these advanced technologies and connecting to the international collaboration, and also we want to bring the industry partners.
Under the mission, each hub will create a proximal technology business incubator or link with existing TBIs. All the hubs will work in a distributed model in the sense that all the incubates may not necessarily be physically located in the TBI, but may avail the services at their own location. Interdisciplinary approach is the focus of the mission. Hubs have to work together for delivering technologies and products. Scientific Advisory Committee and Inter-Ministerial Coordination Committee will ensure the cooperation and working together of hubs. a coordination committee chaired by Secretary DST and comprising members of all heads of hubs will be created so as to ensure better outcomes of the research activities for development of collaborative solutions.
So this is not one technology that's coming in between, but we are having the array of technologies. Therefore, the technology innovation hubs will specialize in one of these foundational technologies, develop what you call the required technologies, and work along with the other hubs so that the final deployable technology will be made available to the users. Therefore, the realization of this mission will be through these 25 technology innovation hubs.
One of the approved proposals focuses on the theme of human-robot collaboration or cobots. Taking the lead in this feat, Indian Institute of Technology Delhi has envisioned a world-class technical resource center with competencies in foundational research, complex system design and vibrant application-focused innovation. They are especially focusing on the fields of medical, agriculture and smart manufacturing.
Under this Technology Innovation Hub for Cobotics, we have proposed 4 major areas. The number one is the medical robotics, the second one is agriculture and disaster management, the third is the defense robotics, and the fourth is the Industry 4.0 factory for smart manufacturing. But I can give another example. For the COVID, we are working on teleoperation of a robot for ultrasonography. Now COVID patients are there and doctors do not want to go very close to them. So a robot hand will do the ultrasonography and the doctor will be sitting remotely behind. So working on that kind of technology, and then similarly in a COVID patients area, we are trying to deploy robots, mobile robots, which will take the food, medicines and talk to the doctors over the internet or over the Bluetooth or Wi-Fi. Similarly, for the smart manufacturing, for the small industries, they do not want to have very expensive solutions, fully automatic. So if I have a mobile robot which can do things, but with the assistance of the human being, so even the medium scale industries should be able to adopt this kind of technologies.
The mission aims to create robustly productive and sustainable hubs. The development mechanism will be a bottom-up revenue model in which the initiation of the hub is by government support through the National Mission of Interdisciplinary Cyber-Physical Systems for developing capabilities and gradual build-up of resource generation in the later years of the project period.
When we have these 25 technology innovation hubs, we also have along with them the 25 technology business incubators. The TBI will have infrastructure, will have the mentoring capacity, the industry collaborations and the live problems. So therefore, that is an aggregating point where the research is getting translated into a product and as well as the churning out of the startups.
The mission has multiple objectives and encompasses knowledge generation, technology or product development and commercialization, human resource development and skill development, innovation, entrepreneurship and startup ecosystem, and international collaborations. The selected TIHs have prepared and submitted their dream proposal for groundbreaking innovation plans. The Indian Institute of Science, Bengaluru has an ambitious vision of making robots, drone innovations, data sets of artificial intelligence and automated guided vehicle research. We visit Professor Bhardwaj Amratur, Professor in the Electrical Communication Engineering Department at IISc Bengaluru, and understand from him and his team the practical rollout of cyber-physical systems and their wide applications.
So we are focusing on multiple different innovations. One is the area of mobility. With 40% of the people living in cities, and as you know, our cities are so congested, traffic is such a problem. How do we solve this problem? One way of solving this problem is to go vertical and the skies. The Class G airspace, which is the airspace up to 400 feet from the ground level, that airspace is free. How can we construct roadways, or what we are calling skyways here, so that we can have drones actually fly around safely and securely in this airspace?
Technical Associate of Robotics at IISc, Aditya Verma Sagi, works closely with Professor Sharma in developing futuristic machines. He demonstrates to us the different technologies based on intelligent systems.
Basically, this robot was developed here at IISc in our lab, and we are trying to explore reinforcement learning, machine learning approaches.
For example, what is the equivalent of a traffic junction in the sky? How do we create equivalent of roads in the sky? As you know, most of these drones will be flying autonomously. There won't be a pilot in them. These will be small drones. How do you manage all these drones so that they don't collide with each other, they don't collide with other people? And many of these are problems which right now no one in the world has solutions to. So this is a great opportunity for us in India to actually develop these technologies. And hopefully these technologies will go out into the industry as new startups.
The government's objective is to foster and give an impetus to the domain of cyber-physical systems in India's leading technological institutions, and to develop a range of super-intelligent machines that have the capability to analyze data and solve complex problems. These innovation hubs will serve as incubator centers, with the technologies they develop to be scaled up at the commercial and industrial level.
We have to be totally future ready, because this is going to have impact which is significant on everything we do, whether it's about the skills, it's about education, it's about the nature of jobs, it's about every sector. So if you're looking at health, you're looking at these new diagnostics, you're looking at telemedicine, delivery of health services, you're looking at agriculture, transport, energy networks, water networks, wherever you need to optimize things, wherever you want them to be intelligent. So you're going to have cyber physical systems working there. The global impact is going to be so substantial, both in terms of jobs that we need, that we need to develop, and the skills we need to develop, which is why mission has such a big emphasis on education, on training, on skills, as much as also producing new knowledge, as well as consuming new knowledge to convert that into new opportunities. Using these technologies, we want to create new opportunities, deliver services which cannot be delivered now with the old technology, which means you basically expand the applications, you expand reaching out to larger segments of society. So all of that is going to happen in this particular mission.
The mission aims to create a strong foundation and a seamless ecosystem for CPS technologies by coordinating and integrating nationwide efforts encompassing knowledge generation, technology and product development, innovation and commercialization. Scientific giants of India like the Indian Institute of Technologies, Indian Institute of Science, Indian Institute of Science Education and Research, and Science and Engineering Research Board are taking the lead in realizing this Herculean task. Being part of CPS mission, the coordinating institutes function in a network mode with multiple forward and backward linkages with each other. The first phase of NMICPS focuses on establishing innovation hubs based on 6 technology verticals, including artificial intelligence and machine learning. Now, AI is the ability of a computer program or a machine to think and learn, while machine learning is an application of artificial intelligence. Second up is technologies for Internet of Things and Everything, sensors, actuators, and control. IoT is a technological concept in which daily life objects are equipped with electronic components software and sensors and are connected to the internet and to each other. These objects act in an intelligent and sensorial way and collect and transmit data. Next is data banks, data services and data analytics, which includes a pool of information on a particular subject or group of related subjects stored and used via a computer system. Moving forward, the next vertical is advanced communication systems, which is a key aspect of all the verticals, especially in the context of communication with a specialized machinery via specially developed software. The next vertical is one of the most explored areas of machinery and technology, robotics and autonomous systems. This is the branch of technology that deals with the making, programming and designing of robots. The last vertical is cybersecurity. The very core of CPS is the cyberspace. CPS and IoT play an increasingly important role in critical infrastructure, government and everyday life. Automobiles, medical devices, building controls and the smart grid are examples of CPS, and so it is essential to develop software that can help guard this cyberspace. So, how are these technology verticals useful in taking the CPS dream forward? Take the example of our crossroads and the installed red lights. Imagine sensors installed at these intersections that are optimized in a way that they reduce the wait time for the passengers. It would decrease the number of accidents and also bring down fuel consumption. So everything that we do manually today, if it could be done with sensors, it would have a huge impact on our daily lives.
For example, inventory control. So in a big factory, you have lots of information coming in from outside, and you need to factor in that information in order to make certain kind of models or not to make certain kind of models. Where is the demand? Do we have all the raw materials coming in? So all of that stuff is done much better with machine learning than with the way we do it now. There is also, you see, this COVID-19 time is telling us more and more that the future is all digital, it's all cyber. If you look at the development of virtual reality or mixed reality, augmented reality, that's all going to be part of our everyday life.
CPS technologies provide a cutting edge to the nation's scientific, engineering and technological innovative capabilities. It supports our missions of the government like Make in India. The technologies also provide global industrial and economic competitiveness and have truly become a strategic resource. The mission serves as an engine of growth that benefits national initiatives in health, education, energy, environment, agriculture, strategic security and industrial sectors. Innovation, entrepreneurship and startup ecosystems are an integral part of NMICPS. The startups will help create a number of technology-driven job opportunities in CPS and related areas. It is estimated that about 40,000 jobs will be created in the short term and about 2 lakh in long term.
I think the Atmanirbhar Bharat is a very timely initiative by the government. Of course, it follows and develops and is built on top of the Make in India initiative. The Atmanirbhar Bharat is essentially saying that we have to be self-reliant in what we do. And if you see, our world, our society depends a lot on technology now. And all these technologies are largely made in the West and outside the country. One of the visions of Department of Science and Technology to create these technology innovation hubs is to really change that. Can we actually create fundamental technologies and have them go out into the society and be made available to the citizens? So some of these new problems which we are talking about in robotics, in drones, etc., offer a great opportunity for us in the country to actually be in the forefront of this technology development.
Although cyber-physical systems have been applied in many fields, In the larger context, it is still in an embryonic stage, but with great potential. With India's leadership in information technology, its world-class technological institutes, and the added advantage of a national mission on interdisciplinary cyber-physical systems, the country is well positioned to embrace this technological revolution and become a global hub for research and development of cyber-physical systems and its wide applications.